Welcome again to my YouTube channel. In today's video, we are going to discuss the difference between regression trees and classification trees. So, in the previous video, we have already discussed about decision trees, and we have done the numerical problem of decision tree also. So, I suggest all of you to just go through those videos once before proceeding with this video, so that you get to know what are the basics of decision trees. So as that is clear to us, so now we will proceed with regression trees and classification trees. So when we talk of regression tree, here we know this is also known as continuous trees algorithm or continuous variable algorithm. When we talk of classification, we know this is categorical attribute type trees. So we know when then the target variable is continuous, then we perform regression, and when the target variable is of categorical type or discrete type, then we perform classification in that case. So that's why decision tree are known as CAT, that is classification and regression trees. So talking about the distance or difference between these two, we know that the regression trees are used The regression trees are used when the dependent variable is continuous, and the classification is used when the dependent variable is categorical. So in case of regression tree, when we have to obtain the value for the terminal node as the result is presented at the terminal or leaf node. So in that case, the training data is the mean response of observation falling in that region. So if an unseen data observations fall in that region, we will make the prediction with the help of mean value. So when we talk of regression tree, we go with the mean response because we are using the continuous variable. Continuous variable means values like 35, 46.2, 37.2, 58. So likewise, if we are having values like this, these are type of continuous type of data, and if such data is there, we can take the mean to get the result at the leaf node or the terminal node, which is the result in that case. So in that case, we go with the regression tree. Same tree is used, we need not to use any different algorithm. The only thing is the difference between the target variable. The algorithm will provide the result accordingly. So when we talk of a classification tree, the values of class obtained by the terminal node in the training is done with the help of mode. Why? Because it goes with classification goes with the priority. Like suppose we are having few classes with having positive result and two nodes with negative value. So in that case, we have to go with the majority because the resultant answer in that case will be positive. Now in such a case, if such value is there, we are taking the maximum number of values, which is known as mode. So mode of observations falling in that region. Thus, if an unseen data observations falls in that region, we make the prediction with the help of mode, and that is done in the case of regression tree. So both the trees divide the predictor space, that is independent variables, into distinct and non-overlapping regions. Also, both of these trees follow a top-down approach. No, nothing is like one is following top-down or bottom-up. This is following the top-down approach. So you should always remember that when we are implementing CART, that is classification and regression trees or decision trees, then in that case top-down approach will be followed, because we will always start with the root node. Our first problem or the first step in the case of decision tree will be to decide the root node. So for deciding the root node, we should calculate the entropy and the value of information gain, because the information gain of an attribute will decide which attribute is going to be the root node. So if you have not gone through the video of entropy and information gain, then the video is available on my YouTube channel. So you just go through that video once. And so both of the trees are following top-down approach, that is also known as recursive binary splitting. It is used because we are beginning with the top of the tree and the observations are available in a single region and successively splits the predictor space into two branches down the tree. If the it is known as greedy because the algorithm cares, that is looking for the best variable. Best variable will be decided with the variable which is having the highest information gain. It is about only the current sublet and not the further sublets, because for each and every subtree we have to go with the new sublet. The separating process is continued until a user defined stopping criteria is reached. We can tell the algorithm to stop once the number of observation per node becomes less than 50. So that is that can be used as a you can say baseline or a threshold value. So in both the cases, the splitting process results in fully grown trees until the stopping criteria is reached. The fully grown tree is likely to overfit the data and loading to poor accuracy or unseen data. It will bring pruning. So pruning is one of the technique that will tackle the overfitting, because we have to stop at a certain place. So that is the main role of performing excuse me, pruning in this case. So that's all about the difference between regression tree and classification. If you have any doubt, then you can write in the comment box. Also, I will suggest all of you to go through the video of decision trees, entropy and information gain, and the basics of decision tree should be watched for understanding regression tree and classification trees. And the numerical problem of decision tree is very much important for competitive exam point of view. If anybody is preparing for gate examination or any other competitive examination, then that video numerical problem of decision tree, also like naive ways, all numerical problems are available on my channel. So you just watch that video and you will get a very good understanding of those. So thanks for watching the video. If you have not subscribed my channel yet, do subscribe the channel. So thank you.